Welcome to Marrow School. Let's look at a classic problem in mathematics. A mountain bike was originally purchased for 10,000 rupees, but after 3 years of riding, its value has dropped. Specifically, it drops down to a final value of 7,290 rupees. Assuming the same compound depreciation rate is applied at the end of each year, the question we need to answer is, what fixed percentage of its remaining value did this bike lose every single year? Let's lay out our exact variables. The original value, V0, is 10,000. The final value after 3 years, V3, is 7,290. Time, T, is 3 years. We are solving for R, the annual compound depreciation rate. You might occasionally see older textbooks use P and PT instead, but the math is exactly the same. This is the official CDC compound depreciation formula. Notice the minus sign right in the middle. We use minus instead of plus because the asset is losing value over time. Since our goal is to find that annual rate, R, our mathematical mission is straightforward. Substitute our known numbers into this equation and carefully isolate that variable. We start by plugging in what we know. 7,290 equals 10,000 times 1 minus R over 100 cubed. To isolate the parenthetical term, divide both sides by 10,000. This simplifies to exactly 0.729. Keep this exact decimal to avoid premature rounding. That quantity remaining inside the parentheses, 1 minus R over 100, is our annual retention factor. It represents the exact fraction of the bike's value that is capped each year. Now we face a small mathematical hurdle. We have an unknown expression raised to the third power. How do we properly remove it? A very common mistake here is trying to divide by 3, or assuming the powers can just be randomly crossed out. Never do that. 729 and 1000 are exact cubes. We rewrite the fraction as 9/10 cubed. Take the cube root of both sides to remove the exponent. This leaves 0.9 equals 1 minus R over 100. Rearranging gives R over 100 equals 0.1, making R exactly 10. And there we have it. The annual compound depreciation rate for the mountain bike is exactly 10% per annum. Let's verify this to be absolutely sure. If the depreciation rate is 10%, the bike retains 90% of its value each year. Starting at 10,000 rupees, after year 1, we multiply by 0.90 to get 9,000 rupees. In year 2, we multiply that remaining 9,000 by 0.90 to get 8,100 rupees. And in year 3, 8,100 times 0.90 brings us perfectly to our final given value of 7,290 rupees. The math is fully verified. Now, let's look at the overall drop. Over 3 years, the bike lost a total of 2,710 rupees. That is exactly 27.1% of its original value. Do not make the mistake of dividing that 27.1% total loss by 3 to find your annual rate. Compound depreciation applies the percentage drop to the remaining value each year, not to the original starting value. Let's lock in what we've learned with a quick checkpoint. Why is there a minus sign in the formula? Because the asset's value decreases. What does the 0.90 represent? It means the bike retains 90% of its remaining value each year. And which algebraic operation removes the third power? Taking the cube root of both sides. Here is your complete, clean solution chain one last time. Follow these steps and you can confidently find the depreciation rate in any scenario. Marrow School. Learn, understand, succeed.